My being an artist very much affects my view of the world, and it bleeds into everything, including my science. For me, science is about the search from the outside in, whereas art is the search from the inside out. One of the connections between art and science is storytelling. One of the outstanding mysteries of star formation is how stellar nurseries are born and how they evolve. I'm Dr. Nia Imara. I'm an astrophysicist and an artist. And this is how stars are born. Stellar nurseries are incredibly complex, and they have this beautiful, intricate structure weaving throughout them. We know that that structure is intimately tied to the birth of stars, but how that structure itself forms and evolves is still a mystery. Stellar nurseries are enormous. They have tens of thousands of solar masses worth of gas and dust, and they stretch for tens, if not hundreds of light years across. When you look toward the constellation of Orion, just below the belt and stretching above the belt are two of the closest stellar nurseries to us. The Orion stellar nurseries are just about 1,400 light years away, which is just our backyard for astronomers. The Orions are two of the largest, most massive stellar nurseries, and that's the closest region of massive star formation. A star is born when vast regions of interstellar gas and dust come together over the course of millions of years. Eventually, some regions within those clouds of gas and dust undergo gravitational collapse, becoming so dense that eventually nuclear fusion kicks in. And when that happens, a star is born. I once did a sketch of myself touching a star. I wondered, what if we could touch the stars, or at least look at them up close? Part of the challenge with astronomy is that images are inherently flat. Much of that information is collapsed onto one plane. When we're dealing with structures that are much more complicated than spheres, like stars and planets, it can become really challenging to interpret what's going on. And so it's really important for us to find clever ways to be able to visualize the structure of stellar nurseries. 3D models uniquely tap into the human brain's ability to detect patterns. And so that was the idea behind the 3D printing, was to have a new way of visualizing stellar nurseries. These sorts of visualizations don't have to compete with our traditional images. It's just a new way of seeing things and hopefully thinking about things. Each of these prints represents a stellar nursery that may be tens or even 100 light years across. The white material represents the dense gas, the filaments where the stars are going to be born, and the clear material represents the voids of interstellar space. Each of the prints is about the size of a softball, consisting of thousands of layers, each thinner than a piece of paper. Now, most astronomers hate dust. Dust can dim the light from background stars and galaxies that we're trying to observe. But I love dust. Stellar nurseries are dusty, and we can use our knowledge of dust to understand the structure of molecular clouds. Stellar nurseries are threaded by these long, dense, noodle-like structures called filaments. Embedded within filaments are these compact knots of gas called cores, the final stage before star formation. My collaborators and I ran several computer simulations, 9 in total, each representing different physical extremes. So one simulation might have had stronger gravity, another simulation might have had stronger or weaker magnetic fields. And the whole idea here was to be able to get a sense of how the different physics operating in interstellar space shape the environment of stellar nurseries that eventually go on to form stars. And really, one of the most challenging parts of this research is getting the computer simulations right. We're able to get a much better understanding of the physics that's shaping star formation. The link between humanity and the cosmos, we literally come from the stars. That means that we have a common origin, a common destiny, and when you really think about it, we're all responsible for each other. The link between art and science, for me, is my love of color and my love of light. When I think about how Black and brown people have been making major contributions to the sciences and the arts for millennia, I think about people like Benjamin Banneker, George Washington Carver, brilliant scientists and artists who served people with their science and really changed how people think about what a scientist is and what a scientist can be.